Hello, everybody. Real quick, I want to go over some information so I can get you on your snow day. Cool stuff. Get out there, build a snowman, whatever you want to do. So, bell ringer. Here we go. Describe the Stroop effect. How does this effect hinder our ability for signal detection theory? So, you want to pause the video and answer the question, and I'll describe it and discuss it a little bit more. All right, so Stroop Effect. We talked about that yesterday. Obviously, I wanted to have like a game with you challenge to see who can earn an extra credit point with that, detecting what colors and who can detect the colors quicker. But it is what it is. I mean, we'll move on with it. We'll maybe try it another time. So with the Stroop Effect, we went over the colors and how with signal detection theory we can perceive something, right? We're perceiving a sense, and we're understanding what that sense is. And it really depends on how it depends on the environment. It depends on our sensory adaptation. But for the most part, when we detect something, that's our signal detection theory, how it crosses our absolute threshold. And if there's a difference threshold, right? If the stimulus is stronger in sensation, or if it's diminishing, whatever it might be. So with the Stroop effect, it was the colors, right? They first start out with the colors. It's like, oh, hey, what's the colors? And then you just go through it, you label them, you go red, blue, as fast as you can. And then they have the words. So you have to say the color of the font, right? And at first, it's easy. If it's the word is red, it will be red, and then it'll go through that way with blue, and it will be blue. But then they change it, so the word will be red, okay, and the font color will be green, and that causes an issue with us because we want to read. We see two different, I guess you could say, stimulus, right? And it causes a hindrance. It causes a delay with our perception of that color or that word. All right, because it's showing a word, but the color's different on that word, if that makes sense. So with the Stroop effect, that's something that I think is interesting. There's obviously delay. The more you move past that, and the words that come up along with the different font colors describing that word. I think that's pretty cool. And then yesterday with the blind effect. All right, so we're going to talk about the optic nerve here soon and the blind spot in your eye. And with that X, okay, when you're staring at the circle, the dot, when you're looking at that for a long period of time, okay, with a one eye shut, that X will disappear. For me, even the whole circle on the other side disappeared because after a while, once you're focusing on one area, one distinct spot, okay, sooner or later, those photoreceptors, okay, are not visible. Obviously, with the optic nerve, there are no photoreceptors there. There are no rods and cones. And after a while, once you're staring at a certain object, it might be in your blind spot. And with cars, okay, same thing. Like when you're driving down the road, when you look in the mirror, there is a blind spot there, depending on where that car is located on the side of you, whether you're passing someone or whether someone's passing you. And it goes along the same type of analogy, I guess you could say. All right, so there you go. Please work on your vocab. Okay, I know there's quite a bit of vocab terms, but I just want to make sure that you guys are working on that. Not due anytime soon yet, but I mean, try to work on them. All right, real quick. So vision. All right, we're going to talk about the anatomy of the eye more tomorrow, okay, and describe the different parts of the eye and how that helps us visualize information and how that all works, where it's going to be sent back to the occipital lobe for us to perceive what we're visualizing, what we're seeing. And that's a pretty cool, interesting topic as well, which we'll get to. All right, so real quick, the only thing we're going to talk about today is the retina, which is the back part of the eye. Okay, these are where your photoreceptors are located. So your cones and rods, which perceives color and shapes and different types of objects, right? And it sends that information through electrical signal, okay, to different cells, which process that, okay, to the optic nerve. It's almost like it's projecting this light being projected on the back, and your retina is like the back screen, and your fovea is actually interesting part where the fovea is a part of the retina, which there's only really cones located there. Okay, and the cones accept light. Okay, and with that light, there's really no rods there to try to detect different types of black and white and shape. It's mostly just color. And it's interesting because the fovea is actually directing a lot of that light being projected on the back of the retina. Okay, the fovea is just this small little part here Actually, it's not really shown there. That's weird. So with the fovea, it sends that information to the optic disc, and the optic disc sends that information, electrical impulse, to the optic nerve, which will later be perceived in the brain. All right, so this is kind of what it looks like. Here's a better representation. So light's coming in through the cornea, all right, we'll talk about that. And the iris, depending on how bright that light is or how dim that light is, might adjust, okay? And same with the lens. So the lens it accepts this light coming in through the cornea, and then the iris will bend that light depending on how bright or how dim it is. And then it's almost like the projection screen, and it screens that light on the back of your eyeball where the retina is located. The retina stretches all throughout here. And then the fovea is this direct spot where there's a lot of cones located for color. And then that information is sent, like I said, to the optic nerve, will be processed as electrical impulse, a signal sent to the occipital lobe. And then there's different layers, which we'll talk more about, okay, more tomorrow. All right, so how the eye works. So number one, light entering the eye triggers photochemical reactions in the rods and cones in the back of the retina. So like I mentioned before, it's being accepted through the lens here, right? Okay, the cornea, and then in through the iris is going to adjust the light depending on how bright it is. And then the lens is going to project that on the back of your eyeball, okay, where the retina and the fovea are located. Two, chemical reaction turns activated by bipolar cells. Okay, the bipolar cells are like the middleman. Okay, and then as this light's being received by the cones, okay, and the retina, mostly the cones because with color and everything like that. Okay, that light is going to be signaled to the bipolar cells, which the ganglion cells in the back of your eye, okay, the back layer of the retina, will send that neural impulse, okay, to the optic nerve. You can see the optic nerves right here. And interesting enough, with the optic nerve, there is no rods and cones there. So that's why they call it the blind spot. Because if light is ever projected there, if there's any type of sight being projected to the retina or the optic nerve, forget about it. You're not going to see it. And that's kind of what that representation showed yesterday with that small little dot. And three, bipolar cells that activate ganglion cells, like I talked about, axon, which covers the form of the optic nerve. The nerve transmit information to visual cortex in the occipital lobe. So this light's being projected mostly at the fovea. The fovea is collecting this information, right? It's collecting the light, the different type of signal, I guess you say light, and different types of sight coming into your eye and the retina and the fovea. They accept it. Okay, the cones and rods collects that information. The bipolar cells breaks it down. The ganglion cells then send that information down the retina to the optic nerve, the blind spot, right? And that is going to be sent as electrical impulse to the brain. And it happens quick, obviously. It happens at a fast, alarming rate to a point where we process this information without even having to think about it. It happens simultaneously. All right, so photoreceptors, real quick, is the last thing I want to go over. Well, two slides. Light sensitive cells, neurons, okay, retina that convert light to energy into neural energy. So photoreceptors is collecting that light coming in through the eye, and it's sending that as a neural impulse to the brain to be processed as transduction, right? So rods are photoreceptors that are especially sensitive to dim light, but not color. So rods mostly focused with dark, okay, dim light, more like spatial features, right? And let's say when you first wake up, okay, you are very sensitive to the light that turns on in your bedroom. Let's say your mom's waking you up to get to school. Okay, the light comes on, you're like, oh, it's too bright, it's too bright, because your eyes were closed for so long, for a long amount of time, that the rods are actually collecting more information being sent and transduced to your brain. So that is going to be very sensitive to you at first. So it's like you have to close your eyes and make sure that your eyes adjust to the light that's being projected in your room. And then the cones, photoreceptors that are especially sensitive to colors, but not dim light. So same thing with the cones, it's collecting colors, it's collecting different types of brighter light. And let's say you walk into a dark movie theater. Right when you walk in, let's say the screen's off, you can't see nothing. It's just like you're blinded in a way. But after some time, because your eyes, your photoreceptors are adjusting to the dark, dim light, okay, you can see spatial features in the theater. You might not see colors, but you can kind of see what people, the shapes of people, and you can kind of maybe depict where objects are so you don't run into them. I think that's pretty interesting. Like I mentioned before, here's the retina in the back of the eye. Okay, in a way, it's called the background, right? The back screen, okay, where that light's going to come in and be projected on the retina. And then the fovea, like I mentioned before, is that dense area where there's thousands of photoreceptors, mostly cones. And that information is going to be sent to the blind spot. Here's the optic disc, they call it, and the optic nerve is obviously connected to that. All right, that's all I got for today. Enjoy the snow day. Have a good time. Enjoy it. And there's a video attached, so check that video out. It explains a little bit more in detail. All right, have a good one, guys. See you later.